Hello, astronomy. So this past 2 weeks, we've been learning about the solar system. We've been learning about planets. We learned about asteroids. We learned about orbital mechanics and gravity, and even how scientists know what elements to find in the atmospheres of these planets. Um, but there's lots of things about the solar system that we haven't learned yet, and a lot that we're just not going to have time to learn. Um, so in our own solar system, and just as recap, when I say that word solar system, I mean everything that has an orbit around the sun is a part of the solar system. Everything, and remember, our sun is a star, so everything that orbits around this star that we call the sun is a part of the solar system. Um, so there are lots of things that are going around the sun. There are planets. There are 4 terrestrial planets: Mercury, Venus, Earth, Mars, and 2 gas giants, Jupiter and Saturn, and 2 ice giants, uh, Uranus and Neptune. And there's tons of asteroids. But there's also other things like Kuiper Belt objects, dwarf planets, meteoroids, comets. Lots of things in the solar system that we're not going to get a chance to talk about all of them, but hopefully we're going to talk about some of them this week. Uh, but one question that we haven't really answered yet is, how did all of this get here? Um, how did the solar system form, and how's all this stuff still here? So that's what I'm going to talk about real quick, is solar system formation. So one thing we did talk about already is we talked about stars. We talked about when a star dies, when a star explodes, it leaves behind a cloud of dust called a nebula. So no matter if it's a big star or a small star, when it dies, it leaves behind this thing called a nebula. And nebula is like a big dust cloud. So whatever was inside that star when it died is now in this big dust cloud called nebula. So most stars are made of hydrogen and helium, probably some carbon and oxygen. And the really big stars, as they die, fuse stuff like iron, gold, and silver, and all of these elements that can be found on the periodic table. They're left in the nebula. And we know that new stars are eventually born from these nebula. That's one thing we talked about. So when a new star forms, remember, new stars form because gravity is attracting that dust to come back together. The star explodes, but then that dust will want to come back together. Now, this takes a very, very long time for that dust to come back together, because remember, the smaller you are, the less gravity you have. So, for example, I have a gravitational influence, but it's a very small gravitational influence. I can take my coffee cup, and if I drop my coffee cup, it's going to fall toward the earth. It's not going to fall toward me, because the earth has much more mass than I do. So just imagine tiny pieces of dust trying to attract each other gravitationally. It's going to take a very, very long time, but it does happen. We know it happens, because we can see it. We can see these pictures, like the ones I'm showing you right now, which are called Protoplanetary Disks. Now they're called Protoplanetary Disks, um, because planets are forming there, but also stars are forming there. The main thing that they're forming is stars. Planets are kind of just a byproduct of this process. Inside stellar nebula, you have all this dust trying to come back together, and it begins spinning and spinning, getting hotter and hotter. And the really hot part is going to form a star. So in the picture on the right here is a really cool picture, because you kind of see that there are these bands here, which I'll talk about in just a second. But the stuff in the center of this disk is going to eventually form a star. Now, these bands here are actually planets forming. So you can't actually see the planet, but you can see that the planets are eating pieces of dust. So just as the dust will attract each other and eventually form a star, some parts of the dust in what is called this disk, which is actually called the accretion disk, some of those pieces of dust will, instead of going toward forming a star, they will run into each other and form planets. And once you have a planet that's big enough, it'll attract more and more dust faster than just a tiny piece of dust could. So it's kind of like a runaway domino effect. You have two pieces of dust meet each other, and those two pieces of dust now have a stronger gravitational influence. Now they can attract 4 pieces of dust, and 16 pieces of dust, and it goes on until you get something really big. Well, once something gets big enough, it'll attract a lot of dust. And so that's what's happening as each time these planets orbit their mother star here, they attract more and more dust, which kind of clears out an orbit. They're kind of vacuuming out that part of space from all that dust. That's why we see these lines here. In theory, or that's the hypothesis anyway, which I'll get to in just a second. So as the disk, as those globs of dust grow more and more and more, a planet will eventually form. So this is called the Nebular Hypothesis. So just as dust goes to create a new star, it can also create a planet. Really the big difference between a planet and a star is that, well, one has enough mass to ignite nuclear fusion, and planets do not. You might remember us talking about brown dwarf, which kind of blur the line because they almost have enough mass to ignite a nuclear fusion reaction, but not quite. So things like our planets, Earth, and even Jupiter are not nearly massive enough to have nuclear fusion inside the core. The core of planets are still very hot, but not nearly hot enough for nuclear fusion. So instead of forming a big ball of plasma, these balls of dust just become big balls of rock, which is what the Earth is really, if you ignore the water, is basically a big ball of rock. So this idea that nebulas, which are big clouds of dust, can collapse and form stars and planets are called the Nebular Hypothesis. And it took about 5 billion years for whatever nebula was left behind to form our current solar system. So what does it have anything to do with anything about like planets, asteroids, and meteoroids? Well, there's lots of leftovers. So the process of forming the solar system is pretty much done, but there's lots of leftovers. So kind of to draw an analogy here, whenever you cook something, you're gonna have lots of leftovers on your skillet or on your pot or your pan, right? Unless you're really hungry or you're really like a really neat freak, after you're done serving yourself or serving your family, you have lots of little scraps left on that pan. So you can kind of think of like your spoon or your plate being like the big planets are taking most of the chunks of your food. But even after your spoon runs through the whole pot, you're still left over with little scraps. This is especially true if you ever try to scramble eggs. You're not going to eat all those tiny little burnt edged pieces on your pan. It's same is true with our solar system. After all the planets and asteroid belt and all that stuff is formed, there's still lots of leftover stuff hanging around. And sometimes even asteroids and comets can leave more leftover dust. So our solar system is full of this dust and tiny pieces of rock. If you remember that earlier picture that I showed you, let me go back, of where planets are sweeping away all of this dust here. Well, that's what happened to our solar system. Our solar system doesn't look like this anymore. Our solar system is mostly empty, except for the planets. Remember I said that these planets are kind of vacuuming the dust. Well, that's still happening. The Earth is still vacuuming away the dust anytime that, remember the Earth is going around the sun at a very fast speed, 65,000 miles an hour. So anytime the Earth runs into some dust, well, it's going to sweep that dust and kind of collect that dust. So in our solar system, we have lots of these leftovers of when the solar system were formed. Any rocks or dust grains smaller than 10 meters across or 32 feet across are called meteoroids. Anything bigger than a meteoroid is called an asteroid, which we already talked about. So meteoroids are just these rocks. Could be the size of just a dust grain, or it could be up to 32 feet across. It's a meteoroid. If a meteoroid enters a planet's atmosphere like ours, it's called a meteor or a falling star. You see a picture of a falling star on the left, and I think a lot of you guys have told me in your first videos that you've seen falling stars before. If most meteors burn up in the atmosphere because, well, actually, I won't get into why they burn up, but they do burn up, and it's very hot for that falling star. But if it does happen to escape the burning process, if it actually makes it to landing on the Earth, it's called a meteorite. So meteoroid, meteor, meteorite. I'm not going to make you memorize those, and it does seem a little bit confusing. Why would we come up with three different terms about of those three things? But it really just helps scientists understand and kind of categorize what belongs in space and what actually belongs to planets. Because once a meteoroid becomes a meteorite, once it becomes lands on the Earth, it's now a part of the Earth, because that's partially how the Earth formed. It formed from space dust, and space dust is still landing on the Earth. It's not nearly as violent as it was when the Earth was forming, but we still receive about 60 to 100 tons of space dust per day. Now that's spread throughout the entire Earth, so it's kind of like a sprinkling here and there. But the Earth is still receiving that space dust every day in the form of what you might call micrometeorites. So that's what we're going to be learning about this week. We might get into comets and dwarf planets if we have time. But definitely the focus this week are going to be on meteors and meteoroids. So thanks for tuning in, and I'll talk to you later.